Hello, hello.
Hello.
Hello, Amanda. Thank you for saying hello. Hello, Amanda. Thank you.
Good
Hel-
afternoon.
Oh, good
Hello.
afternoon. Who was that? Cheska. Good afternoon. And hello. Oh, sorry. What? Oh, okay. Good. So, hello, Amanda. Good afternoon, Yavi. Thank you. And I think that was Cheska before. I'm not totally sure, but good afternoon, Yavi. Good afternoon. And I'm going to say hello whether we do or not. Good afternoon. How you? And again, everybody, please tell me when. Oh, there's Christopher. All right, now we're in video. It was excellent, excellent. And if you think I'm going to say hello like we're going to do hellos like this every single time for 2 semesters, you're right. But it'll take less and less time as we go. I promise. Um. Okay. So hello, Christopher. Hello. A lot of people. Okay. Okay. Hello, Melita. Thank you. And again, everybody should tell me if I'm when I'm mispronouncing their name or when I'm using the wrong pronouns or anything like that. Oh, sorry. Who else do we got? Hello, Michelle. And who did I just skip? I just said good afternoon, Avani. And hi, Yoon. Excellent, excellent. Okay, we're getting there. We're getting there. Okay. Good afternoon, Matthew. Awesome, awesome. Oh, there's Michelle. Awesome, awesome. And Avani. Excellent. See, we're rocking and roll. Good afternoon, Matthew. Or did I just say that? I apologize. I might have. Or no, that was Michelle. Good afternoon, Freddie. Awesome, awesome. Good. Hello, hi you. Awesome. Okay, okay, we're getting there. We're getting there. We're gonna. All right, who else did I not? Who did I not? Did I say hello, Marilyn? Hello, Marilyn. If I didn't say hello to someone, hello, Alonzo. I should have said that because he has an avatar. Sorry about that. Hello. Good afternoon, Amanda. Oh, okay, good afternoon, Amanda. Oh, and here comes someone. Oh, oh, and who's that? It is. Hello, Giselle. Excellent, excellent. Okay, excellent. Hello. Oh, see, you know how many points she just got? Literally, like that's video, that's a hello, and that's voice. Like that's 3 different portals right there. We still have to get used to this. I'll be talking about all that stuff less and less as we go on, as we get used to it. But forgive me that I have to talk about it a lot in the first couple of days because some of it is a new system for a lot of people and something to get used to. But it'll be true for 2 semesters. Hello, Cheska. Oh, or did I say that right? But good. Oh, good to see. All right, now you gotta wait. Oh, I'm gonna start a portal for waves, for physical waves. Okay. Okay. So this is awesome. All right. We have things to do. And if I didn't say hello, I apologize. Let me know. But okay. And who's that? Oh, closed captioning. Cool, cool, cool. Okay. English. Okay, cool. Okay. Um, okay. So I want to, so today we're going to start getting into physics. And we're going to start going over the homework and we're going to start talking about, and we're going to completely talk about the 5-step method. We will get that out of the way. It will still be too slow of a start for some of you. I'm going to warn you of that right now. I promise you that physics is going to, each class is going to go faster and faster. It's going to take us less and less time just to get straight to it. Oh, chat. Oh, cool. All right. Thank you, direct chat person. I see. No problem. Uh, oh, okay. I'm just going to warn you right now, at least based on the experience of this morning. Like, there's a lot to lay out about this class to get used to at the beginning. It's sort of boring to keep talking about. I know many of us are anxious just to get straight to the homework and start going over it. We will start going over the homework. And I promise you that, again, that each day it'll take us less time to get rolling. And eventually classes are going to go fast enough that you're going to sort of some of you might be wishing that we were back in the slower days. Again, it's a 2-semester experience, so just bear with me at the beginning my goal at the beginning, honestly, is not necessarily to entertain everybody, although that would be nice, but to make things as clear and comfortable for as many people as possible. My goal at the beginning is to put everybody's minds at ease that everybody has a chance to understand how this class works and to do this class and to do well in this class, like regardless of what kind of background you're coming from or what kind of comfort you think you have with physics, etc. Which means that the first couple of classes for some of you are probably boring. But I apologize, just bear with me. So we have like a lot of bookkeeping and housekeeping things to still get out of the way. such as I don't even think, and you might want to tell me in the chat. And again, so based on my experience this morning, it took us a while, but eventually we started going over homework 1 by the end. We went over one question of homework 1. Honestly, I'd like to get to a little bit more than that in this section, but we got to one question in homework 1, but in that one question, we were able to go through the entire 5-step method and hopefully make that clear to everybody. So we will get to it today. But some things had to be clarified first. So stop me at any time with any questions at all. This is the time to do that. Let me start by, so for example, I think I've talked a lot about grades and points and things, but I don't think I've actually, and tell me if I'm wrong in the chat, I don't think I've yet actually explicitly told you where all these points go or how your grade actually works. And even though that's like really boring to talk about, I think it's fairly important for everybody to understand, again, because it's true for 2 semesters and it will help you know how to approach this class. So tell me if I'm wrong in the chat. I mean, in the chat, tell me if I'm wrong, but I believe I still have to actually tell you where all these homework points are going and how they work. I'm correct. Okay, thank you very much. So thank you for putting it that way. Thank you. All right, awesome. Okay, and does that mean also I'm correct in thinking that you would like to hear about that? Is that okay? Okay, yeah. All right. So we will. And one of the reasons I'm going to talk about all that today too, I'm going to start by. Okay, sure. Okay, that's a more. Okay. I'm going to try to do this all in context. I'm going to start by saying that even though if you got a 15 on homework 1, if you got a 15, let me make clear to you right now, that's not a percentage. Sorry, that is not a percentage. And it's like, that doesn't mean that you got a 75%. And it doesn't mean a C, definitely not. And it's not a final score at all. Like I tried to write that in the classroom, but it seems to be unclear to some people. The 15 first, and let me even be more clear. If you already got a 15 on the first homework out of 20 points, that means at this very moment, you've gotten all the possible points you could possibly get at this moment. It means there's nothing wrong with anything you're doing thus far in this class. Okay. You turned in a first draft to me on time. Thank you very much. Technically, I mean, assuming you did, and a couple people didn't, and we'll talk about that in a minute too, but assuming you turned in a first draft of homework 1 for 3:05 p.m., then first of all, yay, thank you. Second of all, let's be clear, it was technically due at 3:05 p.m. So even if you did hand it in super early or something, I have not gone through and made any comments or given any feedback or looked at any of the details of anything you've done yet at all. All I've done so far is just check to see who has actually made a thorough attempt to actually respond to all the questions in the homework and to attempt to do it in the formatted way that we're going to expect for the rest of 2 semesters. In other words, if you did turn in a PDF or a Google Doc or something that didn't have any of my questions copied and pasted in it, and that had a bunch of work of yours on it with a bunch of thought processes and a bunch of answers circled, then I'm saying, excellent. That's the first thing I was just looking for, to see if you even made that attempt and if we're sort of on the same page and the system's working. So you've already you have so far gotten 15 points out of the 20. I consider what you did a rough draft. You could consider the grade a rough draft if you like. Now, so you couldn't have gotten any more than 15 so far. I haven't even looked at the details yet. It's just an acknowledgement of thank you. Now, I'm going, and this also will start to indicate to you how all the homework and everything works. Okay, now, when I get a moment, like after this class or tonight or whatever, of course, then I'm going to start looking at it in more detail. I'm going to start providing more feedback. The first thing I'm not going to look at answers, right? I'm going to look at, did they try to do the 5-step method? Do they have 5 steps for each question? Do they have a diagram? Blah, blah, blah. We'll talk about all that today. And that's how I grade things. And if you have all the steps and you've addressed all the questions and all that, and it looks clear and considered, then it's quite possible that then tonight or something, I'm going to be like, check. And then your grade's going to go up to a 20 for many of you. Like, it's very possible that many of you actually are going to end up with a 20 on it without having to do anything more. Like, it doesn't mean anything's missing. It means I've looked at only 75% of it so far. Okay. So don't, if you got a 15, don't think that's a problem. Don't think you're supposed to do anything yet. wait for the rest of the feedback and wait for the rest of the score. If you get a 20, you're done, move on. Let's say in the case of some of you, let's say when I start to actually look at it, then I do find, oh, wait, even though they have the right answer here, even though they clearly are smart and they totally in their head did the question 1 and question 2 and they get it, but they didn't show all the steps, and we're all about showing all the steps now for good or for bad. So I start taking off points. I'm like, you're missing step 2 here, you're missing step 3. So say you end up only getting a 17 or something. Okay, then, and you'll find that out in a couple of days. Then that still means, okay, you have gotten 17 out of the 20 possible points so far. It means you probably do want to do another draft. It means you're going to pay attention to the rest of this class or to the end of the class where I explain how to do the 5-step method, or maybe you made a physics error, maybe. And so then I explain some physics today or the next class, and then you see the error. So then you use today's class or whatever other resources, and you go back and you upload a new file, which is totally fine. Like you upload a revision and keep the old file. We'll talk about that in a second. And so then I'll look at it again, and then you'll get a 20. So the first thing I want to just make clear to everybody before I get into the whole grading system is, in principle, with every homework, with every homework, your job is to make a valiant first attempt and do so on time. And you'll get a bunch of points right away to acknowledge that you did that. Then everybody can revise and upload as much as they need to in order to get all of the remaining points on a homework, especially on the first homework. Every single person in this class who wants to get the full credit on this homework will eventually get all the credit on the first homework. Okay. Now, in theory, that also applies to all the subsequent homeworks, but it gets harder and harder. Like, as the semester builds and we get a lot more work, it'll be hard to stay on top and to be doing tons of revisions to everything, but you're always allowed. So the first thing I want to make clear is I consider homeworks drafts and I consider grades drafts. And in principle, you can just keep drafting and I can keep looking until you get all the points on any homework. I still have to explain where all these points are going, but so far, So far, the real thing I'm saying right now is if you got a 15 right now in homework, you should feel like you're exactly in the right place, and you should feel like the rest of the points are coming to you either automatically soon or when you do another draft. Is that clear so far to everybody? Yeah, okay, cool. Thank you, Chris, for nodding. Thank you, Giselle, for nodding. Okay, okay. All right. Now, I still have to answer the question. Oh. I will try my best. That's a good question. Of course, that's more, for me to accept that challenge means I actually have to do real work for a change and actually make a new assignment for the first time in 30 years. So you're really putting me, but yes, I'll try. Oh my God. Okay, good call. Okay, I totally have to open up a portal for jokes, but okay. All right, now I still have to answer the question, where are the points going? But did I forget? But before I do. The other thing is there are, I think, I'm not going to, not going to acknowledge anybody by name, but there might be some of you who's definitely across the 3 sections. There are some people that still haven't handed in the first homework. So here's how that works. Can you still hand it in? Yes, you can. Can you still eventually get all the points on the first homework? Eventually, yes, you can. In terms of homework, am I going to explicitly penalize you for being late? No. But part of the reason that I've already given 15 points to everybody who was on time is to make a clear acknowledgement that I do see the difference. Like if you're just late on the first one because you didn't understand it or whatever, and like you just quickly get yourself caught up and you turn it in tonight and then like it doesn't happen again, I totally understand. And that's why, especially with the first homework, I want to make it clear to everybody that we're here to figure out how this class works right now first. And it takes some people more time than others to figure that out. So even if you haven't turned it in yet, you still can and should, and you're not, grade-wise, you're not behind yet. Of course, now you're a little behind in doing work, and you don't want to fall too far behind because we will start going faster and faster. So that's all I'm going to say on that. And that's all I'm going to say on that right now. Like, just if you haven't turned in the homework yet, just know that I know that, and you don't want to make that a habit, or in the future you want to let me know in advance if that's going to happen, or blah, blah, blah. But still do it. You can still get all the points, and it's far more worth it to do that than not. That's what I'm going to say about that. Now, where are all these points going? where are all these points going? I think that's the key question. The answer is this. Oh, wait. Oh, yeah. Okay. The answer is this. And you may, and someone liked Chris. Sorry. Okay. I have to. Okay. Sorry. I'm just so intrigued by the whole. I just liked it. Oh, that wasn't on purpose, but okay, whatever. I mean, all right. Anyway. Okay. Where are all these points going? Now, this is a little bit unusual, this system, maybe. And it is written in the syllabus, of course, like it's a contract, whatever, but it's like maybe not that clear in the syllabus. It's so you may want to write this down, or if it goes too fast, like whatever I'm about to say about the grading system also applies to Physics 204, and it is a grading system designed to make you do work in a certain way. So if you want to ask me privately later to repeat this or re-explain it, I would not be surprised, and I would not shame you. Also, you can replay the tape, on YouTube later. But it is important to know the following. Here's how it works. You'll have a midterm exam, which we'll talk about when we get to it. You'll have a final exam. You'll have all this work that you do in lab. All of the work that you do in lab will add up by whatever grading system happens in lab. You do all this work in lab, and at the end of the day, all that work in lab ends up to be one big grade that we consider to be equivalent in weight to the 2 exams you take, like for good or for bad. So first of all, to make your exam average, not your final average, but your base exam average, there's first 3 at the end of the semester, there's 3 pieces: midterm, final, lab. Now, technically and usually the midterm is not curved, the final is not curved. You'll hear about why in a minute, whatever. Often they're challenging exams. We'll talk about that too, whatever. But then sometimes there's extra credit and blah, blah, blah. But you have these 3 numbers: a midterm number, a final exam number, and a lab number. First, those 3 get averaged in the traditional way, arithmetic mean, added up and divided by 3, okay? And that makes your base average. Okay, let's say for the purpose of example that's an 81, whatever. And by the way, lab grades are usually pretty, people do fine in labs usually, assuming you show up and you do everything that you're supposed to do. But okay, so you say you have an 81 base average, then all of the homeworks, the regular real physics homeworks that start counting for more and more points as we progress, and all of the game turns, and like the game turns, the game portals, everything that you ever see that has any like points assigned to it, all of those are just accumulating as you go into a big pile of like total points, okay? Other things end up going in that pile as well that you haven't seen yet, like other separate extra credit things that come up sometimes. And also, you'll see anytime I ever have to make a logistical announcement to you, like I have to say, oh, unfortunately, we won't meet synchronously tomorrow. I need you to watch a video instead. Like, so sorry, whatever. If I send an announcement, and it occasionally happens, if I send a logistical announcement to everybody, like tomorrow we're going to be doing things differently, then always when I send a logistical announcement, I will always have a piece in it that says, as soon as you reply to this announcement with the word yes and confirm that you've received on understanding instructions, you'll get 6 points. Like that happens, okay? Or like whenever anything goes on that I want to make sure we're all clear, I'll like say to confirm with a yes that you understand, and you get 6 points. So points are accumulating all the time in this pile called points. Now, and it doesn't make any distinction between regular physics homeworks or any of the other things, just that regular physics homeworks are worth more usually, but there's all these points accumulate. Now, they're not percentages, they're just points. What happens is, at the end of the semester, let's say the typical person has accumulated, for example, 240 points. That's like a reasonable example. Say the typical person has accumulated like 240 points. Maybe it was out of a possible 300. Like maybe I, had 300 points of opportunities, but who cares? It's not a percentage. It's just there was 300 possibilities, and you, the average person, let's say, earned 240 of them. Okay, well, of course, I'm not going to add 240 points to your exam average, because then you'd have like a 300. Like, what does that mean? I can't do that. But what I do at the end of every semester is I have a formula for coming up every semester with one scaling factor that slightly differs from semester to semester, but is the same for every single student. and is designed to help you. I assure you, I can explain this later. But so one scaling factor, say at the end of this semester, the scaling factor is 20. That's also a reasonable example. So that means you can see where this is going. I think for everybody, I take their total amount of points and I divide it by 20. And all of this will be made clear in the grading spreadsheet that you get at the end. You'll see it all, like it'll all be transparent, but I'll take your total number of points and divide by, say, 20. Whatever I divide by is the same for every single student. So if you're the person that has 240 points, I divided that by 20, so that makes 12, right? So guess what? You could see where this is going. So that means I would add 12 points to your exam base average. 12 points is not an exaggeration or an unrealistic example. Obviously, some people end up with a lot less, people that do a lot less homework or less participation, but some people end up with more. But it's a fairly standard example. So that means, and I know I'm talking a lot about this, but I want to make this really clear because it's really important. What that means is that then I add, well, no, so it's not a good question. It's not always 20. It varies from semester to semester, but there's a formula that I use that's the same, and it's always around 20, but it's always designed, the formula is designed. The reason it might be like lower one semester or higher another is because it's designed to make sure that at least some people get A's in the class, to be honest. That's what if it's designed to make sure that the people with the highest grade, it's designed to make sure that, because if no one got an A in this class, that means I'm doing something wrong. So it does vary. I look at, so anyway, it functions almost like a curve, but it's not a curve, it's a lever. But wait, sorry. Oh, thank you. Okay, thank you for acknowledging, for closing the loop. That's the point right there. So, and whatever the divider is, first of all, I promise you it's designed to be to your benefit, I promise. But second of all, you'll know what it is. It won't be a hide the ball thing. You'll see it in the Excel spreadsheet, and it'll be the same for every student, okay? And then, so then after I add, say, 12 points to your grade, then after that, I have the instructor discretion to add one more point to anyone or everyone I please for what we call scholarly initiative. It basically 1 point for what we used to call class participation, except now I have all these things for participation. So basically I can add one more point to your grade after that. If basically you've really shown up, if I know who you are, basically, if you've made it clear that this class is some kind of priority and you're not just reacting in the last minute to things, but you're actually like trying to stay ahead of stuff, you're in some way taking note, if you're just showing a real presence in the class, I can then add 1 point to your grade, to your average after these 12 that already got added. Why would I do that in some cases? Or what? The whole purpose of that is that after all is said and done, after you've taken your exams and all of these points are added to represent all of your daily participation in your daily work and daily efforts and all that, then at the end of the day, the whole purpose is then, if for quirk forbid, you now have like a 92.7. I mean, we've all been there, or 82.7. I mean, I don't think I have to tell you how frustrating that situation is, right? If you're like literally that close to an A or a B or whatever it is you're trying to get out of this class, and then, but then like, boom, sorry, it's over. Like, no, there's nothing we can say. And it's so frustrating. And you've actually worked that hard and you've been a good person. So I can add one more point at the end of the day to push you over a borderline, because I hate borderlines as much as you do. And then it's unambiguous. And then I will say this, then after that, one more point. So you have your base grade average, then you have all these points added that came from everything else you did. And that means from here on in, every time you see a point come in from a game turn or anything, like really in your mind, you can say to yourself, I just got a 20th of a point or whatever, you know what I'm saying? But they're all accumulating. Then at the end, as long as I basically know who you are, you don't have to worry about being right on the borderline, because you'll get one more point to push you over the borderline. Then I stop. Like, then whatever your grade is, and you'll see it in the Excel spreadsheet. Then after that, enough people, believe me, enough people will have really high grades that then there's like no more, there's no more give at that point. And the net result of this whole thing, I'm sorry to overtalk it, but it is an unusual grading system, perhaps. The net result of this whole thing, and then we'll move on. There's a couple of net results, just to be clear as possible. Net result number one is that all of those points that I just described, all the homework points, participation points, blah, 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 please note that not only are they not percentages, they're just points, right? They're like Mario coins. I mean, they're just currency in the class, or they're Nook miles, or whatever in Animal Crossing. But also they're all, if you want to say, and I think someone said this yesterday, in a theory, they're all extra credit, because what this all means is, I'm trying to say there's more than one possible path to an A or whatever high grade in this class. It's meant to be the case that there's different types of learning, there's different types of people, there's different roads to get an A. One obvious road is if you just happen to be a rockin' exam taker, which I was not. If you happen to love exams and you're like, they don't stress you out, and you remember all your physics from high school or whatever, and you're just that kind of person, and you just rock out a 95 on the first exam and a 95 on the second exam, and you do solid in lab like a 95. Now, first of all, that's difficult. The exams are difficult, and a lot of people don't. The average score on exams is not a 95. I can tell you that right now. But if you happen to be that person and you rock both exams and you rock the lab, then Quark bless America, like bless you. Then if you don't do any of these homeworks or any of these participations, you're not getting zeros, you're not getting penalties. You're just going on your merry way and you're getting an A in the class. And I hope you help everybody else with your time. Like, seriously. So one way is you could just exam your way to an A. Now, again, that's hard. The exams, we'll get to it. People don't typically get A's on them, or at least not the midterm. But anyway, but the other path is, if you struggle with exams or they stress you out, or the first, like you have to get used to them, or blah, 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 then as you notice from the example, you could end up with your exams leading you to something like a B minus or something, or even less. You could be getting like C's on the first, you could get a C on the midterm. But because you're doing fine in lab and you do all this other work, in fact, I should say that clearly right now, if you get back a C on the mid, or you get back like a 71 on the midterm, that's fairly common. A lot of people will get like a 71 on the midterm. Don't think to yourself, I'm getting a C minus in this class now. What you should think to yourself is, if you're solid in lab and you're doing all this other work and stuff like that, and you get a 71 on the midterm, you're already probably something like gunning for something like an 83, i.e. a B in the class. That's the point, is that we're trying to say exams matter, but also what people do every single day matters a lot. And for some people, that can make all the difference in rocking this class. So, okay, so all the homeworks and all that stuff is, in theory, extra credit, if you want to think of it that way. You're never being penalized for what you don't do. You're just getting points for what you do. Okay, lastly on that, and then I'll shut up for a second, I'll make sure it's clear. The other purpose of all this, I think I said this Monday, but I just want to make it clear. All this means, I want as many people as possible to earn as high a grade as possible. I design a scaling factor. I look at the grades at the end before the scaling factor. I look at them and I come up with a scaling factor to ensure that at least some people are getting A's. And I can tell you right now, and I don't think that's a gift, and I don't think it's a gift. I think it's just a recognition of all the work you're doing in between exams. When I do that, what ends up happening, I will tell you right now, is a lot of people let me say this more clearly. It means that there's no limit to how many A's I'm willing to submit to CUNY first. I don't believe in that. I mean, I believe in it for some classes, but not for, like, it doesn't work for me. There's no limit to how many A's could come out into CUNY first from this group. There's no prescribed limit. I'm not going to lose tenure or something like that if you all get A's. I'll be thrilled if you all earn them. And the truth is, with a system like this, a lot of you will. When I do pull the lever and add in the points from all your homework and stuff like that to make sure that some people get A's, it usually means a lot of people get A's or A minuses or something like that, or B pluses. A lot will. But I also want to tell you right now, before I move on, this whole system is designed. It's designed to reward different types of work. It's designed to make it easier for you to survive Zoom, because I think that's a challenge. It's designed to make you like physics, because the more you like it, the more you will do it, and the more you will work hard, blah, 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 blah. It's designed for all that. It's designed so that you don't compete, and so that you collaborate, so that you help each other get these A's that are not a limited commodity. But I also want you to know in advance, especially before you get your first midterm scores back, which often do scare people, I want you to know that at the end of this course and Physics 204, if you do get a good grade, if you're one of the many people that does get a good grade, yay, I'm psyched, I'm happy. Don't make the mistake of then thinking, oh, but this was a gift, like this was obvious, it was automatic. It's like a super generous grading system. Like, of course I got an A, like that doesn't mean anything. I mean, he's just a pusher. No, it totally means something, because I'm also telling you right now that the reason I do it all this way is that no matter what I do, every semester, will be a number of you that will not pass the course. There usually aren't a ton of things in the middle. There aren't usually a ton of C's or something like that, because usually the people that just do what they're supposed to do, even if they feel insecure, even if you feel uncomfortable with physics, if you just do everything, you can get a really good grade. But there's always some number of people that just don't do what is expected to do. And it could be for very legitimate reasons, like household, family, this and that. So I'm not saying it critically, but there's always some percentage of people that don't or can't actually do what the class is asking them to do, and they won't pass the class. And sometimes they take the class over, and sometimes whenever they do, I greet them like I'm thrilled to see them give it a second round, and usually the second round goes amazing for them. Like there's no shame in that. But I am saying every single semester, some people don't pass this class. So if you do well in the class, you do need to realize that means you did something. And it's just like the forensic science major at John Jay. Part of the reason that everybody knows this is a real major, and part of the reason that all of you will eventually get good jobs and get into good graduate schools when you're done with this butt kicker of a major, is that the whole world knows it's a real deal that you're trying to do with this major. How do they know? Because they know that not everybody who starts this major finishes it, which means automatic, and I don't mean that critically, but it's just true, and you know it. So any of you who do finish have done something that is not automatic and that's real. And any of you who don't will like I have sympathy for, and you will try again and stuff, and like, but same thing with the physics class. Okay, it's a little bit of a binary situation, but if you do what we outlined, and I'll start getting back to it in a minute, then you'll probably do really well. But it really will be an achievement, because something about this class is such that enough people every single semester can't do it. All right, now, okay. Honestly, first of all, does that make sense? Okay, thank you, Melita. I saw that. Thank you, Avani. I saw that. Okay, thank you, Giselle. Awesome. Okay, so we're again, if anything comes up, if it's not clear, it does say it in the syllabus. You can check again. You can rewatch this movie. You can ask me personally, but that's the deal. So I encourage you to do. So any points you get is good, and any points you don't get, you just don't get. There's no zero. Okay, but I think you get. And so, okay. So now we're going to start going over the homework, I think, in a second, which actually is a little bit faster than the other class. What this also all means, the other reason for all of this, you might have noticed already. It always frustrates or scares some people. What's always going to be, once we get going in this class, like in a minute, we'll go faster and faster every day. What we're always going to be doing in the Zoom room is we're always going to be going over homework problems. And like I said, in that sense, it's like recitation. We're always going to be just going over homework problems. But you'll notice that you get assigned the homework problems first, and then we go over them. That's not an accident. That can be very scary to some people. You might call that an inverted classroom or a backwards classroom or something like that. It's becoming more of like an industry standard, but like we've been doing it that way in physics for a long time. Those of you who already wrote me and said like, wait, did you have a PowerPoint on this like distance displacement thing or so? Like, did I miss the actual lecture where you explained how to do this homework? Like, no, you didn't. And I want to make it clear right now, every time you go to sit down to do a homework, and they will get harder and they will get more mathematical, you will sit down to do something that we are asking you to think through first in your way. And then we will talk about it the next day. Oh yeah, I'm going to totally look at the chat in 1 second, but I think I see, yeah, hang on. And for some people at first, or at a certain point, that's going to be very frustrating. But it's not an accident, and it's not you. Don't feel like you're crazy or you missed something, or don't feel that we forgot something. You try things first, then we explain them. There's many reasons for that, not the least of which is that's really the way actual physics actually feels, and that's the way physics really is. We're not here to teach you about the history of physics. We're here to teach you how to do physics. And how to do physics means that every time you sit down for a new physics problem, it's a new physics problem. It always feels like something that you don't know when you're really doing physics, and especially if you're becoming a research scientist. So the idea, every time you sit down to do a physics assignment, you're going to have a feeling that you don't know what to do. Or if you haven't had that feeling, you will at some point have that feeling. The idea of physics is that every seemingly new thing, every new topic or every new question follows from principles or definitions or ideas that were established in the last discoveries we made. But it always requires a little bit of extra thought and patience and focus and faith to see how to apply the last things to the new thing. What we are above all trying to teach you over the next 2 semesters is not so much physics information. We are here to teach you what to do when you don't know what to do, right? Because that's what it really means to be a research scientist. If you really think about it, we need to teach you what to do when you feel like you don't know what to do. So it will get more and more, and you might not feel that way yet. But that's why there's no textbook that's required. You can get any textbook you want. There's no textbook that's required. There's no PowerPoint presentations to tell you stuff. We give you questions. You try to answer them. You use any resource you want online. You use each other. I hope, please, you use WhatsApp or like a Discord or whatever. You can do whatever you want to do the homework. You can look at Khan Academy. You can look at old videos of mine where I went over the homework already, blah, blah, blah. And that's what you do. But then we realize that that's scary at first. So that's why you get as many opportunities as you need to then listen to the class and go over it and then re-upload and revise according to whatever we did in class. And I'll stop talking about this in a second, I'll go over it. But the reason you get asked the questions first and then we go over them is primarily because people pay a lot more attention when we go over them if they already have thought it through and they already know what they know, what they don't know, and what they need to hear. Once I stop yammering about this, you'll find it's much more efficient if I'm addressing your needs than if I'm inventing things out of nowhere and just asking you to write them down. So recognize that part of the grading system also is designed to acknowledge that you're trying to figure things out, then we're going over them, not the other way around. And eventually we'll get in pace with each other. Okay, wait, there's something in the chat. Hold on. So it's like we get the homework Monday, get it done by Wednesday. Right, I think so. Yeah, like I review it. I'm looking at Christopher's question. I mean, I think the answers to that is yes. Like, so right now, for example, if there's no more questions, 342, I'm going to start going over homework 1. And I'm going to be going over it. And those of you who've already turned it in and are still waiting for your final grade, you'll just be like sitting there making sure that you got it right. And if you think like, yeah, that's what I did, cool, then you'll know you're cool and you'll know you're going to get all the points on it. But those of you who are hearing me say things like, and you realize, like some of you are going to think, oh, well, I totally did know the answer to that, but he wanted me to show all of that work. Like the answer is yes. And then you'll just suck it up and you'll revise it according to what you're hearing me say right now, and then you'll re-upload it. So, but of course, this is all going to become, once we get to like harder things, this is all going to become both more maybe scary to some of you, but also more valuable. Right now, we're at a stage where I feel like with this first homework assignment, we'll find out in a minute. I feel like a lot of you probably could see in your head very quickly the answers to a lot of the questions. Maybe not all of you, and maybe not all of the questions. And if you didn't, that's also fine. But I would imagine that I would imagine that many of you might have thought this isn't so bad, and that's good if you did. So when you find out right now how much work I'm going to say you had to put into these questions to show me the work, some of you are going to be like, really? I had to write all of that down to show you something that I did in my head in 1 millisecond? And the answer is yes. Because I'm intentionally starting with questions I think you can follow to show you a method for breaking down questions that you can follow, so that we all have a method in hand for that moment that always comes in physics, for when we get to questions that we can't see in our head in 1 millisecond. The whole idea here is to find out what to do when we don't know what to do. So if you did know what to do here in this homework, and then you're going to now listen to me and find out how much I've asked you to break it down, You might be frustrated, and I apologize, but the worst thing is I'm asking you to go through some busy work right now that might bore you. I'm asking you to develop muscles and a method that then becomes a life raft that you can climb into on exams when you don't exactly necessarily know what to do in 1 millisecond. So, but yeah, I think the answer to Christopher's question is yes, I think. Tell me if I didn't answer, but all right. All that said, let's go. Oh, wait, sorry. No, is there any other? Is that sort of? Can I start going over homework 1 now? Are we clear? They're like, yes, please, please. Will you go to homework 1? Yes. Okay. Here we go. All right. Homework 1. Yes. Okay. Thank you. All right. Okay. And I'm going to switch the view on the screen. So here's homework 1 starting. I'm just switching the view on the screen. Sorry. And you, again, please interrupt me at any time. You can ask me to go back a slide, forward a slide, whatever. And again, just recognize I'll go faster and faster. Right now, we're getting used to each other, so just indulge me if it, but all right. So this, what I'm putting up here, I'm pretending I'm being you. I'm turning in this homework. So I've taken out a fresh white piece of paper in my notebook or whatever. Or if I'm really savvy with computers, I've opened up, like I've created a fresh Google Doc and I labeled it at the top, like number line, whatever, homework 1. I probably should put my name on it too, but you actually don't really have to with Google Classroom. But okay, fine. Let's say I put my name on it. Okay. And then notice at the top, I've recreated the diagram that was already provided for me in the sheet, right? I didn't do it exactly the way it was in the sheet, but I captured all the information that was in the sheet, and I captured all the facts that were given in the sheet somewhat illegibly. I apologize, right? Like here, what I've done before anything, I did not copy or paste the information from the sheet. I did hand transcribe it. That will annoy many of you. I'm sorry, but it is what I'm asking you to do is to capture all the relevant information from the original problem onto your fresh thing as though this were a blue book, as though this were a science journal article or whatever. And note, and all of this where you're putting down the diagram and the fact pattern of the situation as it was presented, this is step 1, DFP. You see that in red, right? And I'm even labeling it step 1. Like, strictly speaking, if you don't label it step 1, I probably wouldn't take off points, but it's a really good idea to like, especially as you're getting used to this. Here is my step 1 of the 5-step problem solving method. Step 1, DFP, diagram and fact pattern. Now, in some cases, I've already given you a diagram in the problem, so you're sort of just copying it. I understand that, but there's a big difference between you hand copying and just and literally electronic copy pasting. When you hand copy, you're forced to actually process all the information that's there. But also note, and sometimes, by the way, you'll see in homework 2, yeah, I think in homework 2, I don't even give you a diagram there. It's still on you to provide a diagram. So, it just gets more and more harder. Notice what's the purpose of the diagram. That things don't look that mathematical yet. They're going to look a lot more mathematical, but one purpose of a diagram, the diagram doesn't solve anything. The diagram presents the fact, but in the diagram there are labels, and the labels are the kind of letters or symbols, constants, variables that we're going to be using in all the math once the math comes that we use to solve the problem. So like eventually when we start solving these questions on homework 1, I'm going to start writing things down like x and x minus x naught and v equals x minus x naught over t and stuff like that. Well, I don't know what x is as I'm following that math unless x is a label in the diagram. By being a label in the diagram, I've defined the terms of my solution. So one really important thing about a diagram, we'll get into this, is notice and I'm not even sure my sheet did this, but yours should. I've made it clear what my coordinate system is. I've made it clear that to the right is the positive direction. I called it positive x. And to the left is in the negative direction. That's a choice. The whole problem could work just as easily if you made an opposite choice, and you can, but we all have to know what the choice is. So a diagram is what is presented first, where all constants and variables are defined as labels. And by the way, I hope some of you are writing some of this down now, and there's a portal that'll open for notes that are taken that I don't write down myself. But like diagram and fact pattern, this is what I'm looking for. I'm looking for you to define terms through your labels, and I'm looking for you to choose coordinate directions and make them clear. Okay, so here we have the diagram, and then we have the facts. like 3 seconds. Well, the fact got sort of unclear, but there's an arrow that says from 4 to -2, and then there's an arrow that goes from -2 to 4, and it says 3 seconds, and then 2 seconds, and then 3 seconds. And notice that's facts that were taken from the problem, but I've now drawn them. So clearly this is my personal version of all the information in the problem. It shows that I know what the problem is, and it shows the reader, i.e. the grader, what the problem is, right? So that is step one. I'm asking all of you to do that every time. I recognize it's annoying to some of you right now. I apologize, but I'm asking all. If you didn't do this in your homework, you're not going to be punished, but this would be one reason you might want to revise and re-upload. So this is step one. And then, and it says, and then the fact, each interval of motion is at a constant speed, right? That was a crucial fact in the problem too. So I've put that fact up. All right, so here's the situation. That's step one. And stop me if any of this is unclear. So now I go to step two. And right now I'm trying to explain the homework to you, but I'm also trying to explain the 5-step method to you. So that's why this is a long explanation. I'm not saying you're going to do that in your homework every time. You're going to do what's on this piece of paper. But it won't take you as long because you're not going to be re-explaining the 5-step method every time. You understand what I'm saying? So step two, every single time is WIQ. What is the question? Now, this is huge. This is the one that people hate doing, or the people forget to do on exams or don't do. For some reason, for a long time, this seems like the most annoying thing to people. But I'm telling you, it's crucial. On step two, you're in your words now or in your equation, somehow in your symbols, you're going to make clear what the question is. Like Q1, question 1. I wrote a bunch of English in the sheet. You're going to write down something like from t equals 0 to t equals 8, the total distance equals. Now, look, again, right now, this is somewhat foundational physics. Right now, it's kind of in English and stuff like that. We haven't established any equations or anything. Eventually, this would probably be written something like from t equals t, you'd write something like from t equals 0 to t equals 8, absolute value, x minus x naught, absolute value equals question mark. Like, it would probably look more like math, and that's fine. Your job here is to write the minimum down that you need to show that you know exactly what the question is. You're not copying and pasting. You're writing it in your own way. You're taking a step to force yourself to acknowledge literally what the question is. That becomes really important once questions become like hard and confusing. Also, you're making it clear to me, the reader, what the question is. This is really important for journal writing and all that stuff. Whether you like it or not, I'm asking you to do it. I'm telling you to do it. And notice now, again, even though you're submitting this whole thing like it's a blue book, like you're now, by doing this in step two, what is the question? You're also enabling me to follow your work and assess it and grade it without having to look at anything else. Or I could pass it to another physicist. I won't, but I could pass it to another physicist and they could grade it without looking at anything else. You're presenting everything as an independent presentation that is as easy on the reader as possible. That's the job of publishing physics articles or whatever. So you've written the question down from t equals t, total distance equals question mark. That's step two. Please notice this. We've already done 2 out of the 5 steps. We've already done 40% of what I'm asking you to do. Neither of them require doing any physics at all. They just might strike you as busy work, but you're getting points for both of them. You've already gotten 40 points of the problem just by writing this down. This can be really comforting once you start getting to questions that you don't know what to do. You get my point. But similarly, if this were an exam, and you thought you didn't know what you're doing, or you were stressing out, or you're going fast, and you started writing an answer down right now, or starting to show some work, and you skipped this step, you would just see off in the margin -2 WIQ. This is the grading rubric. If you ever see on an exam -2 points WIQ, what I'm saying to you is, I don't care how good your answer is. I need to know what the question is, because I don't know what the question is unless you. I need to know it. Okay, so this is where you get. Oh, yeah. It can be written as Bill. Great question. Wait, sorry. No, absolutely. It does. Great question, Melita. Am I saying that right? Sorry, tell me if I'm. But Melita, I guess I asked you that already. Sorry, but yeah. Totally, it can be bullet points. You'll even find eventually it might just be like, it might literally be something like at t equals 7, comma v equals question mark. Like, it hopefully will be much simpler than whatever full sentences I wrote down in the question. Because this is another quick sidebar thing. Writing physics questions is a little bit hard because we have to like we have to give you all the information you need to do it. And we have to sort of address all the concerns and the confusions you might have. So we have to give you all this information, but then all the information seems really overwhelming to people. It's like a lot. And a lot of the information we give you in physics questions is like information that you'll need later, but you don't all need it once. So, right, your job in step 2 is to actually distill and condense and cut through the garbage. And yes, bullet points, anything simple, you're trying to simplify. Just don't leave out any important information. But yes, right, in step 2, you could just bullet it. Absolutely. And tell me if that made sense. But okay, so that's step 2. What is the question? Now, again, all of this, I'm going to say again, because I'm very defensive about all of this. All of this seems like a lot of overkill for any question that you can just do quickly in your mind. I know that. I'm not trying to insult anybody's intelligence. I know that you don't need to do all of this for some of the questions. But what I know in my heart, having been a physics student many times and been a physics teacher many times, is that eventually you get to questions where you do need to do something. And usually by the time I get to those questions, what people say is, I have no idea what to do. And they just freak out and panic and give up. We're trying to design, there's a middle road. I'm not even going to say this. Things in physics often to people strike them as either utterly obvious and self-evident and not even worth saying. Like when people get things in physics, often they're like, oh yeah, duh. Like I don't even, yeah, of course. Like, duh. Like, okay, distance equals rate times time. Like, why is that even worth talking about? But then when they don't get things immediately in physics, then they're like, that doesn't even, what? That's completely stupid. Like what? I don't even understand what you're saying. What you need, there's got to be a middle ground. It can't be that everything in physics is either obvious or stupid, right? So the middle ground is that a lot of questions in physics, we don't see right away what they're asking or what they're asking us to do or what the answer is or how to get there. But if we were to go methodically, we could get there. So I'm giving you a method that seems like overkill when you already know the answer, but the method is, what I'm asking you to write down is all the steps that your mind must have gone through in order to get to the answer. It just went through so quickly that you didn't care to notice. So we're trying to break down the mental process now when it's manageable and get used to it so that we have something that we're used to and our muscles are trained to do when we get to the questions that we can't answer. And some of you might have even seen some of those questions at the end of this sheet. So anyway, I'm going to stop apologizing. And for anybody who didn't do this last night, I'm not shaming you. How could you know to do this last night? You've never met me before. But if you didn't do it last night, you have a chance to redo it according to this way, as long as it's clear now. All right, so now we go to step 3. Now we go to step 3. Am I back on it? Yeah, let me just erase the chat. I hope that did answer Melissa's question. But all right, step 3, GDP, general definitions and principles. So now you're going to write down the things you know, like, you know, in 7th grade, we used to always do, like, how do you solve a word problem? Write down what you know, and then write down what you need. Okay, there's some logic to that, right? But here's the thing. There's 2 different kinds of knowledge that we have. What you're going to write, you've already in step 1 written down what you know in terms of the problem. In step 1, you've already written down what is true specifically in this particular situation. And then there's a question that the situation has generated. Now this is like how to do research, okay? But anyway, step 3 is now saying, okay, what are things we know in general? What are things that are true in the universe of physics? What are definitions or laws or principles that are true even before we saw this problem, but that somehow might be helpful for this problem, right? So this generally means, yeah, definitions, principles, and laws. So I write down one here. For example, I wrote distance. Like I need a concept of distance here. If I'm being asked what's the distance, I need to know what that means. So I write down distance, and your mind had to do this, even if you didn't bother to write this down. There's no way, if you got this question right, and the answer is 21 feet, by the way, if you got 21 feet in your head, don't think, well, I just knew it. I mean, it just came to me in a dream. No, if you got 21 feet in your head, yes, you're very smart, and I'm psyched. But that is because you did a bunch of steps really quickly. There's no way you got 21 feet in your head unless somewhere in your head first said, well, what is distance? Oh, distance means like everywhere that I went, but like not caring whether I went left or right. Your head had to acknowledge that, and then acknowledged it so quickly that then it applied to it. So anyway, so we're writing that down. Distance is a total amount of accumulated space between 2 points, independent of direction. Will we have a math definition of this eventually? Yes, of course. Right now, I'm just in English just to make sure we're all together. But that's what distance is. Notice. So I wrote it down. That's my GDP. Now, let's note one thing. We want to start getting mathematical and symbolic here. So I'm going to tell you one thing right away. Some of you already know this maybe from like computer science, or there's 2 different types of equals. There's 2 different types of equals, just like there's 2 different types of knowledge. And it really helps to keep them straight in your mind, especially when you're doing physics. 2 things can be equal by definition, in which case we use in physics a triple equal sign. Or 2 things can be equal by circumstance or discovery, like by discovery or circumstance, in which case we use a double equal sign. Now, you may never have made this distinction before. I'm going to tell you it's going to help you a lot if you start making it now. PV equals nRT, like from chemistry, right? PV equals nRT. That's a double equal sign. That's like a bunch of people in a bunch of different labs at a bunch of different times, like noticed like relationships that seemed approximately generally sort of true under sort of certain conditions, like pressure is, directly proportional to temperature as long as it's an ideal gas line, blah, blah, blah. And then volume is inversely proportional. And so they put this whole thing together after a bunch of circumstantial discoveries, and they call it a law, but it is a descriptive law, right? PV equals nRT is not, there's nothing about pressure that in and of itself means that it has to be related in any way to volume or temperature. It just turned out to be often kind of, sort of, approximately, usefully true. That's a double equal sign. But a square equals a rectangle with 4 equal sides and 4 equal right angles, or something like that. That's not a discovery that we made. That's not an approximate set of circumstances that we put together. That's not descriptive. That's prescriptive. A square, or let me give a better example for physics. Average speed, as we're going to see, average speed is total distance divided by total time. That is not something anybody ever discovered, and that is not something that anybody could ever undiscover, and that is not something that has any exceptions at all. If average speed is distance divided by time, if it is true at all, it is fully, universally, rigidly true. It's a definition. It's an invention. When we say that average speed is distance over time, or in this case, if we say that distance is the total amount of accumulated space between 2 points in space and time, independent of direction, we're just saying that from here on in, we don't want to have to use all of those words every time we want to think about that concept. So we invented one word to stand for all of that. Now, I'm yelling and screaming. I apologize. But I want to make it clear that things that are true by definition are true, things that are equal by definition are equal in a far more strong and specific and black and white way than things that are true by circumstance. So we make that, and most of what we do in physics for a while is all going to be just establishing definitions and then taking them super seriously, like more seriously than some of you might be expecting. Anytime we see a definition, we're going to recognize that definition is always true. It might not always be helpful, but it's always true. So generally, step 3, and I know I'm talking a lot, I'm about to move on, I promise. Step 3, general definitions and principles. Step 3 is not always triple equal signs, but often it's triple equal signs. You're doing something right if you've got a triple equal sign or a number of them in your step 3. Step 3 is things that are just true in the universe. Okay, so step 3 in this case was the definition of distance. Again, soon your step 3 GDPs will look a lot more mathematical than this looks right now, but be that as it may. So then you get to step 4. Then you get to step 4, PAW, that says particular application and work. I should put in quotes. Hold on. So step 4, we're going to take this general piece of knowledge that we have, and now we're going to focus in, zoom in, and we're going to apply it to the particular situation at hand, right? This is where now we usually start converting triple equal signs into double equal signs. Now we discover things. Now we're going to plug and chug whatever specific numbers or value or facts were presented in this particular problem. Okay. So I usually transition when I'm writing out a step 4 in a solution or on the board. Usually you could tell that I'm doing a step 4 because I'll usually use a word like here, meaning like in this case now. Here, in this case, we traveled from the +4 to the -2, and that makes a distance of 6, right? Because it's just because I'm not looking, I mean, and if you want an equation, I'll give you that soon, and they'll have absolute values in it and stuff, and if you did that, that's fine. But however you view it, we started at the 4, we went to the -2, so technically what I'm really doing is, if you like, I'm really doing absolute value of -2 minus 4. That's what I'm really, if that, like I'm looking the difference between -2 and 4, regardless of whether it was positive or negative. Oh, sorry. Okay, that's a really good, okay, Christopher's question. So yes, it is. I want to say more about that in a minute. So Chris just said in the chat, so part 4 is basically showing work. Yes, it is. Hold that thought for a second. Yes, it is, but I'm glad you raised that. I'm going to say more about that in a moment. So I'm just going to finish this. So yeah, so I did 6 going that way. Then I came back and went that same route again in the opposite direction. But the whole point for distance is that I don't care what direction I went. So I did 6 again. And then I went all the way from 4 to -5, as you can see. And as I'm sure you know, then I did 9. So I add them all up and I get 21 feet. Okay, then we have step 5 and we'll be done. But on Chris's point, which is, sorry, and by the way, you could tell me in the private chat. I have a Christopher in another class too, who also, is it, sorry. There's also a question in the direct chat. But wait, quick question. Is it Krista? Do you prefer Christopher or Chris? Because I'm going to be using your name a lot. Hold on. Okay. Okay. Touche. All right. Fair enough. Okay. Now, wait. I do want to say more about Chris's comment on step 4. It's an astute observation. I want to say more about it. But even before I do, there's something in the direct chat. I'm very appreciative of this thing in the direct chat. I'm not going to name the person's name, but it is a legitimate thing. Someone in the direct chat wrote, like, I'm a little confused. Do we have to follow these steps exactly or similarly and in our own words? That's a very fair question. I think I can answer that clearly. Use your own words. You don't have to use my words. And when I'm saying things like step 4 is particular application and work, for example, you definitely don't have to write out the words particular application and work or something. I mean, I'm giving each one of these steps a title and like a quick, like 3-letter acronym to make it easy maybe for you to remember. You don't have to use those words. And technically, you don't even literally have to put the label step 1, step 2, step 3. However, so yes, you use your own words. You don't have to use mine. But I am saying to everybody, for good or for bad, I'm saying you need to do all these 5 steps every single time. And you do need to do them in this order every single time. And until we all get used to it, I would advise you to label as you go, step 1, step 2. Like, I would advise that. This is the rubric or the system for you solving these problems. Right, not in my words, in your words, but yes, these 5 things have to happen each time in this order. And part of the reason I'm giving you these silly acronyms like PAW, particular application work, or GDP, part of the reason for that is when you take an exam or do homework, I want you to know in advance, that's how I'll grade it. If you see on your paper -2 GDP or -2 step 3, I'm going to expect by then that you'll understand I don't see a step 3. I'm not saying I don't see the label step 3. I'm saying I don't see a step 3. So it's a good idea for you to label to make it as you're part of the whole point of this is to make it as easy for you to be able to get to a right answer, even when you don't see how to get to a right answer, but also as easy for me to follow your thought process without me having to look at anything else. So before I go any further, the person in direct chat who just asked me that, I think that's a very fair, very important question. I want to know honestly, from the direct chat person, indirect, you can keep it direct, private. But did I answer do you understand my answer? Okay, great. Okay. Now, also for all of you, I know this is like a little unusual. And some of you, look, physics gets hard. Physics gets advanced. And I love it when it gets advanced, particularly in 204. It will. If you're waiting, if you want it to be like mind numbing, it'll happen. I promise you. But that's why we want to make it as we want to have a way of making it as doable as possible before it kicks us in the butt. So for those of you who think this is a lot, I'm going to stop saying it, but trust me, this will make your life easier in the long run. Right now, it'll just make your life a little bit more boring, but I don't think it makes your life harder. So therefore, I'm glad at least one person is kind of admitting they're not totally sure they're seeing what I'm getting at. For any of you, right now we're in the stage, you're going to try this and I'm going to give you feedback. And right now, I'm promising you again, there's nobody in this room that isn't going to eventually get a perfect score on their first homework as long as they want to. We're going to get this right before we go on, before we really need it for the midterm or for Physics 204, okay? So I do want you all to understand, but if you don't understand immediately now, you're just going to try and you're going to find out, and there won't be any punishment for trying and finding out. But okay, I'm glad to now. And we're almost done, and I know 411. Okay, and we're almost finishing this question, and maybe we'll get to the second question. Chris's question about step 4, very interesting. He said, so step 4 is basically where we show work. Well, it's funny that he says that. Yeah. Step 4 is where you show the traditional work that everybody thinks of as the physics work. Like, yes, step 4 is when the action really starts happening, where the plugging and chugging, the plugging into equations, the redoing, the algebraic manipulation of equations, the calculus, where all the stuff really happens, right, is step 4. He's absolutely right. Like, that's the stuff that you would, if I had just said to you, hand in the homework and show all work, a lot of you would have shown a lot of what I would consider step 4 stuff. And you might not have shown any of the first 3 steps. Chris is absolutely right to think of step 4 as where the traditional stuff happens. But let me let you in on a secret, like all of you. And you'll see this more. The thing is, you might have remembered from high school, or you might have noticed in other science classes, or definitely in physics, what tends to happen to people is they get it at first. It seems reasonable and surprisingly manageable at first. And then the teacher or the professor is like making sense at first. And then somewhere along the line, people get homework or exam questions where they're like, I have no freaking idea. I don't even know what this thing is asking. Like, I don't even know I don't even know how to begin. Like, I don't even know what the heck you're asking me to do. I don't even know how to begin. Like, that happens to all of us at some point with physics. And then we either get angry at ourselves and we think we're stupid, or we get angry at the professor or whatever. But here's what what people a lot, and then we come into class the next day, and then the professor explains it, or the high school teacher or whatever explains it. And then often a lot of us, especially good students, people like you who have made it this far, then the next day, a lot of us are like, oh, okay, that makes sense. I mean, I didn't think of that, but okay, I get it now. But then we're like, and then it happens time and time again where we feel stupid at home or something, or angry at home. And then it all seems to make sense. But then we're like, but I can't, okay. People frequently come to me and they say, you know what? I always get it once you explain it, or I always know what to do. I can do the physics once the equations are set up, or once you tell me which equations to use. I can do the physics, people say. I can do the problems, or I totally understand them when you explain them. But the one thing I just never know quite how to do is choose the equations and set it up. A lot of people, a lot of times say that to me. And if you've ever had that feeling before, you are not alone. But I'm here to tell you that's actually self-deception. I mean, I'm sympathetic to it, but it's anybody who says I can do the physics, but I just don't know which equations to use. As long as you choose the equations for me, or as long as you set up for me, then I can do the physics. What people are really saying is I can do the mathematical computation. I can plug and chug, but I don't actually understand the physics. That's what people are, and I'm saying that sympathetically. The truth, and it's ironic because a lot of people think that what's hard about physics is the math, but actually successful students like you, a lot of times end up totally relying on the math, and they totally do get the math, and that's not the issue at all, certainly not the computations, but they don't know how to set it up. And what I'm here to say to you is setting up the physics is the physics. That's the art of the science that does take a while to learn, but it is learnable. It's like the difference between memorizing notes and playing music. The thing that we're here to teach you is actually how to set up a problem, how to know what work you're going to have to do in order to do it. So what I'm really, and I'm not yelling, I'm not angry, I'm just excited that Chris said that. Because what I'm really here to say to you is that most of you will view the first 3 steps that I'm asking you to do right now as the waste of time, and you just want to get onto it to step 4. But the whole thing is that for problems where you actually don't know what to do or how to set it up, steps 1, 2, and 3 will guide you to 4. They'll get you there, and you won't need me to get you there. You just blindly follow steps 1, 2, and 3, and you'll see how they turn into 4 on their own. And then one of 2 things will happen. Either you literally will get an answer to something that you didn't even think you understood when it started, which feels great. Or at worst, even if you don't get to the right answer by the end somehow, because you made an error in computation or something, you will have already gotten like 65% of the points because you wrote down 1, 2, and 3, which didn't require any actual thinking to do. So yes, 4 is what everybody thinks of as the work, but it's 1, 2, and 3 that everybody always skips in their mind, and that's why they don't know how to do the work when they don't. Anyway, you get my point. So now, wait, am I? Oh, okay. So anyway, but you'll see. I'm yelling and screaming because I'm trying to sell you a used car that no one wants to buy. But the tires are really, really inflated. Okay, so that's step 4. Now we go to step 5. Oh yeah, so step 5, FAC, final answer circle. So now you literally put down the actual answer to the actual question that you actually wrote up in step 2, right? The question in step 2 was, from t equals 0 to t equals 8, what is the total distance? And right, and then you started off your thought process with a triple equal sign, with like distance triple equals like this concept, blah, 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 blah. And it didn't have to be my exact words. That was just an example. So now we're all the way at step 5, and we have a complete thought that is actually addressing, responding to, answering the original question. It's a complete thought. It's an equation. It will usually not be in English. It'll usually have symbols in it, but it's literally saying the distance in this situation equals, double equal sign, 21 feet. Notice our final answer is a complete thought. It's not 21. It's the distance under these conditions is 21 feet, 21, and it has units, feet. You usually step 4, when it's complicated enough, you'll be manipulating units while you go in step 4 and using scientific notation and all of that. And this final answer is circled. So at the end of the day, or highlighted or bolded or something like that. So I can look at your work. I can see right at the beginning what the situation is. I can see what the question is. I can see that you understand the question. I can see what concept was used. I can see how you applied the concept to the word. And then you answered your original question. And now what you have at the end, I mean, I just hit an ant with a mallet. I know. Like, obviously, none of you had to write all of this down in order to just, figure out that 21 was the answer to the first question. But I'm telling you that your brain did have to do all of this in order to get the answer. So what I've just asked you to do is take a mental movie of all the steps that your brain went through to get this answer and slow it down and see what the steps were and put them on paper so that you have a movie to rely on when we get to questions, which we will very soon, where you don't immediately see the end of the road. So you circle the final answer, and then you can see, and this whole thing now, especially once it becomes more mathematical, number 1 is a complete work of physics. Like, if you've just shown now how to solve a problem like this in general. You've just provided a mini physics proof. If it happened not to have been a question that we've been asked a million times in society and we've already thought through, you could publish this now. Like, maybe it's not new, but it's complete work of physics. And I could grade it now without having to have any other document or sense of context. So that's how you answer the first question. I'll tell you right now, I know we're about to run out of time. The answer to this, I'm just going to, so you're going to do the rest like this. Oh, when you go to the second question now, do you have to rewrite the whole diagram all over again? No, you don't. For the next question, you can absolutely say, like, step 1, for diagram and fact patterns, see above. Of course, you can do that. And you'll do that for all the rest of the questions, that's for sure. But then for the rest, like, the next question is a new question. And I believe the next question is, what was the total displacement for the entire journey? Just so you can, I'll tell you right now, the answer, I believe, is -9 feet. -9 9 feet. I do want to see all your work for that again, but if you got -9 feet for the next answer, you're doing something right. Of course, again, we're going to go faster and faster in this class. Right now, I'm just trying to lay out everything for you so everybody's cool. And of course, even though it just took me 70 minutes to explain this, it wouldn't take you 70 minutes to do this. Of course, I'm talking about it. So it's 419. So, okay. So, as usual, in 1 minute, it's time to go. You'll go. I will hang out as always until the last person goes. So if you have any questions or any concerns, you can hang out first. I'll stop the recording and you can ask any questions within, or if we met to make an appointment, we'll make an appointment. But let me just change the and we will go again, for those of you who wanted to hear all the answers today. I apologize that we didn't get to that. We will next time. It will go for, I thought, yeah, I think you do. Oh wait, no, it's okay. Wait, maybe I'm crazy, but I think we don't have school on Monday, right? Do we have school on Monday? I thought it was Labor Day. Do we have school on Monday?
You know, it's Labor Day.
We don't. Okay, so that's why. So okay, right. So you do. So you have 2 things of homework for Wednesday, and then we'll catch up with ourselves. Okay, and then there'll be a break if we have to catch up with ourselves. But of the 2 homeworks, one is like very important, but in different. You'll see the train of thought thing. Don't do the problem method for that. You're just gonna answer with your opinions for one. But the average speed homework, you're going to do the 5-step method, and there's no diagram provided to you there, so you're going to have to make diagrams for that. But yeah, so that's Wednesday. There's nothing for Monday. We don't meet Monday. So thank you very much for being so patient. And if it's clear, then have a nice night. I'm gonna stop. But thank you very much, and have a nice night. Okay. Bye. Okay. Yeah, and you could stay on to ask questions. Yeah, I'm just gonna stop the recording. I'm not going anywhere. Hang on. Yeah. Thank you, guys. Have a good day.
Goodbye, Professor.
Bye. Thank you. Okay.